Hello students, this is a video about sampling. Our textbook gives lots of examples on how to do bad sampling. So here we present to you 5 different ways of sampling. We're going to talk about simple, convenient, systematic, clustered, and stratified random sampling. If I have a population of trees, for those of you nature lovers, I might want to know things about a population. To find things about a population, it is common practice to take a sample. A sample is a selection of objects or observations taken from the population of interest. For example, a population can be all the trees in the Colorado mountains at a given time. And I might want to know how tall they are. But perhaps I cannot measure all of them, so we take a sample of some of them, and I measure some of them, and then use these. The choice of the sample depends on the nature of the population and the resources available in terms of time and money. The idea is that every object in the population is equally likely to be chosen. Then we would have an unbiased sample. It's desirable for the sample to be representative of the population. If the population of the trees were 1/3 of them red and 2/3 of them green, the samples should be similarly split. Okay? Now, know that there will always be sampling error or variation due to sampling, as we are looking just at a part of a population, not the whole thing. In this video, we're talking about 5 types of sampling. For each method, we find the process and the advantages and disadvantages. So the advantages with a green arrow, disadvantages with a red cross. We start with simple random sampling. This is theoretically the ideal method of sampling. You list each member of the population and then use random numbers to decide which objects are in the sample. Imagine you put the list of everybody and then you pick randomly. Each object is equally likely to be selected. And this produces an unbiased sample that we hope that it's also representative. However, it can be difficult or expensive to take a sample when dealing with all the people in the world. So simple random sampling will be more practical when the population is geographically concentrated, also when a good sampling frame exists. In other words, a good list of all the people and objects in the population of interest. Simple random sampling can be easily implemented, for example, in metropolitan areas. Now, convenient sample. Convenient sampling is just convenient. You can ask people nearby, people who walk past you in Pearl Street. Or if you're in Mexico City, or in Beijing, of course, you can stand in the traffic and just sample the 20 cars next to you. This is a question that always comes in the exam. The professor can always poll his class. You do what's easy. So, convenient samples are often biased. But if you need a quick and cheap poll, you can have a convenient sample, especially if biases don't really matter. Convenient samples, of course, can have self-selection bias when people choose to participate because they have an interest in the issue in question. So they're inexpensive, they're fast, but they can have bias. The next one would be systematic sampling. Systematic sampling, you choose a starting point at random and then systematically take objects. 1, 2, 3, 4th. 1, 2, 3, 4th. 1, 2, 3, 4th. Starts at random and then systematically get objects. So if you have 1,000 objects in your population and you want a sample of 250, you would take every 4th object. Systematic samples are easier to administer than simple random samples, and they are usually a good approximation of a random sample. However, if there's a pattern in the population, certain objects would be more or less likely to be picked than others, like in this case, the American footballs. Clustered sampling. In cluster sampling, the population is divided into clusters, and then the clusters are chosen at random. This can work, for example, department of businesses or suburbs within a city. With each clusters, all of the objects included are considered in the sample. Cluster sampling can be more convenient and more practical than simple random sampling. However, if the clusters are different from each other with regard to the elements that we're measuring, it can lead to bias or non-representativeness. For example, here we have all these black cars when in reality the population is really little cars, just to put an example. Stratified sampling. Stratified sampling seems like clustered sampling, but the strata or groups are chosen specifically to represent different characteristics with the population, for example, location or ethnicity or age or occupation. So, within each group, a random sample is taken, sometimes in proportion to the size of the group. If you have many blues, you take more blues, right? Stratified sample can lead to a very good random representative sample. However, it can be complex to administer and you need a very good sample frame with considerable information about the population. There are other sampling methods, but the 5 explained here give you an idea of the advantages and disadvantages of various methods. You should attempt to use the method that produces the best result given the resources that you have available. If your sample have some bias, then, well, just take into account and make sure you tell it in your report. Okay, see you.